Good evening. Today we are going to see in the previous classes we have seen to propose a hypothesis we used find S algorithm which proposes the maximally specific hypothesis. Then we have seen candidate elimination algorithm which proposes a set of consistent hypothesis which we called as version space. And in the candidate elimination algorithm we have seen the inductive bias in which we assumed that our potential hypothesis consists in the set of our search space. Moving further, today we learn ID3 algorithm. Actually, this is a decision tree algorithm. This is proposed by Ross Quinlan. This ID3 stands for iterative dichotomizer, iterative division into two or three spaces, so it is called ID3. The purpose here is, instead of a hypothesis, we will build a tree to take, which will help us to take a decision based on the given training examples. Now the problem we have is this is the data that we are considering. Here we have a data of 14 days in which a given player will play tennis or not. If he plays tennis, then it is answered as yes, otherwise it is no. And his playing tennis depends on 4 different attributes: outlook. Let me write that. 4 attributes. One is outlook, which has values of sunny, overcast and rain. So sunny, overcast or cloudy and rain. These 3 are the values of this first attribute. The second attribute is temperature, and the values we have, it can take are hot, mild or cool. 3 values. So temperature, the values it can take are hot, cool or mild. Then the third attribute, humidity, which has only 2 values if you see the table: high and normal. High and normal. So humidity, high and normal. It is a binary attribute, 2 values. Then wind, 2 values, weak and strong. So wind, weak and strong. It is again another binary attribute. So we have 4 attributes based on which these values are based on the values of which whether on a given day he will play tennis or not, that will be decided. We want to build a decision tree from these attribute values from the 14 days of data. Now the question comes, I think you know pretty well what is a tree. So we will be having a root to the tree. So out of these 4, which should be placed as the root? That is the question now. The question in our discussion is, among the given attributes, how many attributes are given? 4 attributes, 4 in this case. Maybe in other problems there may be more than that. Among the given attributes, which attribute should be placed at the top or root? Now one more fact about ID3 is, it's a top down approach. Top down, we will be starting from the top, and it is a greedy approach. So it is not the context to explain what is top down and what is greedy approach, that we will discuss in the appropriate time. So the question is, which attribute among them, which is more important, which is more prior? So what is the measurement? What is a measure to decide or to determine which attribute gives more information in the data? Statistically, a measure called entropy, which is a prominent property in thermodynamics, it is defined, entropy is a measure of disorder or impurity of the given data. It's a measure, it's not absolute value, it is a measure, or it is a disorder, measure of disorder or impurity. For example, in the given data, there are 3 positive examples and 3 negative examples. That means this data is evenly distributed. We cannot take any decision from this data. Whereas if the data we have is 3 positive and 0 negative, that means from the data I can take a decision, my decision would be yes or positive. Or otherwise, if it is 0 positive and 3 negative or 4 negative, whatever it may be, then I can take the decision from such data very easily, and I can say that my decision is negative. So these later 2 examples, they are helping us to take the decision very easily. So that means they are pure, no impurity, they are pure or ordered. That means there is no disorder. That means entropy is 0 for this. Similarly, here also entropy is 0. Now, let us propose an equation for calculating the entropy of a given data. I will come to it, how this entropy will be. So, entropy is calculated as, let me paste it here. Entropy is calculated from the formula Pi minus Pi log base 2 of Pi. Here Pi is the fraction I. For example, if I take this 3 positive, 3 negative example, what is the fraction of positive? P positive is, there are 3 examples out of 6 examples. So, the Pi is 1 by 2 or 0.5. So, the entropy is entropy of this set. Again, this is P positive. P positive. Similarly, what is P negative in this? 3 negative examples. So, P negative again 3, total number of examples 6, that is equal to 0.5. So, the entropy is minus fraction log base 2. Be careful, by default in our calculators we get logarithm base 10, but here in entropy calculations we will be using logarithm base 2. So, you have to be careful when you are doing the problem. Log 2 0.5 minus P negative into log 2 of P negative, again the same value, again the same value. So, this is how we calculate the entropy. Now, how we can use this as a measure for determining how much information an attribute will provide us? We have defined another parameter in this ID3 algorithm, that is known as information gain. So, we will see, we will calculate information gain for each attribute. How many attributes are there here? 4 attributes, and for the attribute for which the information gain is high, we will place that at the root. This we will do iteratively. Now, let us see how to calculate this information gain. So, the information gain is calculated from the formula total entropy minus, suppose you take an attribute. For example, here the attribute is, let us say, outlook. Outlook has the values sunny, overcast, rain. So, here total entropy minus number of examples of outlook by total number of examples into entropy of the outlook, entropy of that attribute, So, we will be understanding it while we calculate that. So, with these two formulae, number 1 calculating entropy, number 2 calculating information gain for each attribute. So, for that we need logarithm base 2 calculation. So, I have prepared an Excel table for that calculation. You can do with your calculator. This is our data. So, first let us calculate the total entropy for the whole set. Let us call this set as S. So, let us calculate the total entropy. Let us make a table, that would be better. Attribute number of positive examples, that means yes, number of negative examples, that means no, and obviously then maybe you can add total. Then what is the entropy? What is the entropy? Now the total, for the total set, let us see how many positives and how many negatives are there. Now this is the plate NS. Now let me see how many S are there. Now 1, 2, 3, 4, 5, 6, 7, 8, 9. I am using filters in Excel. So there are 9 positive examples out of 14, and obviously 5 will be negative. 1, 2, 3, 4, 5. So 9 positive examples and 5 negative examples. When we take 9 positive and 5 negative examples, now here I prepared a table to calculate So what is the entropy? How to calculate the entropy? Entropy is, there are 9 positives and 5 negatives. So how do we calculate? We calculate using the formula how do we calculate? Fraction of entropy of S. How many positives? 9 positive and 5 negative. So the entropy is equal to the fraction of positive 9 by total 14 into log base 2 9 by 14 minus, of course minus is there, minus negative examples fraction. Negative examples fraction is 5 by 14 into logarithm base 2 of 5 by 14. So when we do this calculation, I have done through the Excel, the value is 0.940. So directly I am writing here the entropy, the total entropy is 0.940. Now we will calculate the entropy of each attribute. From the entropy we will calculate information gain. So now let us go to the outlook attribute. In the outlook attribute we have 3 values: sunny, overcast and rain. In each attribute we will calculate how many positives are there, how many negatives are there. From that we will calculate the entropy of each attribute. Now let us see, take sunny. Now sunny. So let me clear the filter from this. Now outlook, in the outlook, sunny. How many examples are there? Totally 1, 2, 3, 4, 5 examples are there. Out of 5, 2 are positive, 3 are negative. So 2 positive, 3 negative. So what is the entropy? Entropy is, because it is 2 by 3, 2 positive and 3 negative, 2 positive and 3 negative for the sunny. Entropy of outlook is equal to sunny is, there are 5 examples. Out of 5, 2 are positive, so the fraction is 2 by 5 into logarithm of 2 by 5. This is minus the negative examples, 3 by 5 logarithm of 3 by 5 base 2. So this value, my Excel table shows me that value is 0.970. How many examples? 2 positive. What is this attribute I am taking? Sunny. And this is 2 positives and 3 negatives. Totally 5 examples. 0.970. Then another attribute value is overcast. Let us see how many examples are there for the overcast. Again, apply the filter. Overcast, 4 examples are there. All of them are S. That means I already told you, when all of them are either S or no, we can say that it is pure, it is ordered. So entropy will be 0 because it is 4 comma 0. It is 4 comma 0. 4 plus 0 minus. So the fraction is, positive fraction is 4 by 4, that is 1, logarithm of 4 by 4, and by the way, logarithm base 2 of 1 is 0, minus negative examples 0, 0 by 4 into logarithm of 0, which is not defined, but 0 into something is 0, so the entropy is 0, because we can take a decision directly. So the entropy for the overcast, 4 positive examples and 2 negative examples, 0 negative examples, totally 4, and the entropy is 0. So here 4 and 0. So because log 0 is not defined, we will get an error, but let me make it 0 here. That will help me in other calculation. Now coming to the rain. How many examples? 1, 2, 3, 4, 5. Out of 5, 3 are yes, 2 are no. So 3 positive and 2 negative. And let us calculate the entropy using the same formula. We will get 0.970. So this is rain, 3 positives, either it is 2 positive, 3 negative, or 3 positive, 2 negative. Because it is empirical calculation, the entropy, the measure of disorder or the impurity is the same. So now we got entropy of all the 3 attributes of overlook. Now let us calculate information gain. So information gain of in the subset S, the attribute is outlook, is total entropy of S, the total entropy minus the fraction. The formula is SV by S. Now the first one is sunny. So number of sunny, what is the number of sunny examples? 5 examples out of 14 into the entropy of sunny. What is the entropy of sunny? 0.970. 0.970 minus the number of examples for overcast, 4 out of 14 into entropy 0 minus the number of examples for rain, 5 by 14 into entropy 0.970. So this value is, hope you will also calculate .246. In the similar way, you can calculate the entropy of the second attribute, the temperature, hot. Now let me clear filter from here. I will show you one more example and I will go further. So here in the temperature, 3 values, hot, cool, mild. Let us take hot. How many examples? 4 examples, out of which 2 are positive, 2 are negative. So what is the entropy? Entropy is here 2 and 2 even. That means entropy is maximum. That means entropy will be 1. Entropy will be 1, you can see here. See, remember, the entropy, the measure of disorder is, it oscillates from 0 to 1. Sorry, this is 0 again. This is y value 0 and this is y value 1, the entropy here. So when x is equal to 0, the entropy is 0, the fraction, and x is equal to 1 is also, this is 0. When x is equal to 0.5, pi is equal to 0.5, the entropy is maximum, that is 1. So entropy is always between 0 and 1. There are no negative values for the entropy. Entropy is 0 when it is pure set. That means all yes or all no. Then that situation entropy is 0. If half yes and half no, the entropy is 1, the maximum. So here 2 positive, 2 negative, entropy is 1. What about cool? Now let me cool. Cool, again 4 examples, 3 are yes, 3 positive, 1 negative. The entropy is 0.811. How many examples? 4 examples. Then third one, mild. How many examples? 1, 2, 3, 4, 5, 6 examples. In 6, 3 plus 1, 4 are positive and 2 are negative, and the entropy is 0.918. So what is the entropy here? What is the information gain of the temperature? What is the information gain of the temperature? information gain is of temperature is total entropy 0.940 minus the fraction of heart, 4 examples out of 14, into entropy of heart. Entropy of heart is 1 minus cool, 4 examples out of 14, and entropy is 0.811. Then minus entropy of mild, 6 examples out of 14, and the entropy is 0.918. And the information gain, when you calculate this one for the temperature, is 0.029. So similarly you can calculate the remaining two. When we do that, information gain for outlook is 0.246, information gain of temperature is 0.029, information gain of wind is 0.048, information gain of humidity, which has high and normal, is 0.151. So which has the highest information gain? Outlook has the highest information gain. So when we draw, we will place outlook at the root because it has high information gain, and it has 3 values. What is one value? Sunny. Another value, overcast or cloudy. Then another value, rain. Now when we come here, overcast has all positive examples, all 4 positive. That means here the answer, decision is yes. Now the question is, we have 3 more attributes: humidity, temperature, and wind. So where should we place this? Here or here? Again, outlook is equal to sunny, and humidity. So now what we do is, instead of dealing with whole data, we will deal with the data I will take outlook as a sunny. Now I will deal with what I am calculating now, humidity. So humidity has 2 values, high and normal. So with outlook as sunny, I have 5 examples. High, 3 values, all the 3 are negative. All the 3 are negative. That means 3 and 0 and 3. So I will calculate the entropy. When 0 and 3, what is the entropy? 0, right? Because it is ordered. So humidity is equal to strong, 3 examples, all the 3 are negative, 0 plus 3 minus, the entropy is 0, and outlook is equal to sunny, and same, humidity is normal. How many examples? 2 examples, and all those 2 are S. All those 2 are S. So, outlook is equal to sunny, and humidity is equal to normal. Two examples, 2 are positive examples, 0 negative, so entropy is again 0. What is the total entropy here now? Earlier total entropy was 0.940, but now I am calculating only for outlook is equal to sunny. So, when I am calculating outlook is equal to sunny, 5 examples, 3 to 5, out of that 3 are negative, 2 are positive. For 3 negative and 2 positive, let me clear this table. So, 3 positive and 2 negative, the total entropy is 0.970. So, the total entropy is 0.970 for this situation. 0.970. So, information gain of outlook is equal to sunny, and humidity. Total entropy 0.970 minus total 5 examples, strong 3 examples out of 5, the entropy of the strong is 0, minus 2 examples of normal out of 5, entropy is 0. So, the information gain is 0.970. Information gain for outlook is equal to sunny and humidity. So, it is 0.970. Similarly, you can calculate information gain for outlook is equal to sunny and temperature. .970 for temperature, 3 values are there: cold, hot and mild. And here the entropy is, the information gain is 0.570. Then information gain of sunny and wind is 0.970 minus 0.019. So, out of wind, temperature, humidity, which has more information gain? Humidity. So, we go back here and we will place humidity here. Humidity. humidity has 5 examples, and humidity high, humidity normal, and humidity high and normal. High 3 and there is no, so no positive, only negative examples. So here we got one decision, here we got another decision, yes. So here we need not place anything. So again we have to calculate information gain for with rain for wind and temperature. Then we can fulfill the tree with the similar calculation. Here will come wind, and if wind is strong, no, and wind is weak, yes. So in this algorithm, what we are trying to do is we are trying to build a tree by calculating information gain. Information gain is calculated by a property called entropy.